Hi there once again, and how are you guys doing? Well, I just want to welcome you right here for this lesson on iTTV. And my name is Mr. Joe, your tutor for this lesson. Alright guys, so we have started off with transformations 3, and we have actually learned and revised actually the first two types of transformations, which is translation and reflection. Well, now we're going to continue with the next type of transformation, because we're actually going through, and going through again all those 4 types of transformations. So the next type of transformations, and you guys have already learned it, let's take it a look again, is rotation. Alright, now let us go into the details of rotation first. Rotation means turning around a center. The distance from the center of rotation to any point on the shape remains the same. Every point on the object makes a circle around the center. Alright, so rotation has an effect like the clock hand, which always revolves around the center of the clock. So in a rotation, the image is actually rotated in a certain angle, in a certain direction, whether it is clockwise or anti-clockwise from the center of rotation. Now let us take a look at some illustrations on rotation. First example, rotate each shape as described in the diagram. What letter will you get? Alright, now let's take a look at this diagram that we have right here. Okay, so we have 2 objects. And notice that we have 2 dots as well. Alright, take a look at the blue object. We are going to rotate this object 90 degrees anti-clockwise about the blue dot. Alright, for the red object, take a look at the red dot. We're going to rotate 90 degrees anti-clockwise about the red dot. Now, when we rotate both of them according to the details of rotation right here, what letter do you think you will get? So now let's take a look, and let me just rotate this for you. Alright, so take a look at this diagram right now. So take a look at the blue object first. Notice, that we have actually rotated it 90 degrees anti-clockwise. So just visualize, the movement, and you will arrive at an image. Alright, take a look at the arrows that are formed. The arrows simply indicate that the distance from a particular point on the object must be the same from the center as the distance of the corresponding point on the image from the center. Now, what about the red object? When we do the rotation as well, you will get the image as seen, and notice that the arrows actually will help us. So just visualize it. There is a rotation of 90 degrees on both. So we will get the letter L. Okay, so now let's take a look at another example, and I want you to try to visualize it. So guys, remember that in rotation and in transformations in general, what is very important is the ability to visualize and to be able to catch where the image will be, and it always comes naturally with more practice. Let's take a look at this example. Rotate each shape as described in the diagram. What letter will you get? Alright, so let's take a look at this diagram right now. So we have 2 objects. The blue one, rotate 90 degrees anti-clockwise about the blue dot. The red one, rotate 90 degrees anti-clockwise about the red dot. Okay, I want you to try to figure out what letter will you get when you rotate both of them according to the rotation specifications early on. Alright, now let's take a look at this example. So we have 2 objects right here. So what I want you guys to do is take a look at the blue object. I want you to rotate 90 degrees anti-clockwise about the blue dot for this object. Okay, and at the same time, I want you to take a look at the red object, and I want you to perform a rotation of 180 degrees about the red dot. Alright, so what happens and what alphabet will you get when you rotate both at once? Alright, so try to figure them out right now. Alright, now let's take a look at the solution, and you will get the letter I actually. Alright, now let's take a look at object by object, starting with the blue one. Okay, the blue object rotated 90 degrees anti-clockwise about the blue dot. Just imagine and visualize it. Alright, going into a position 90 degrees, alright, from the blue dot anti-clockwise. So just imagine it, alright, rotating, alright, from 12 o'clock to 9 o'clock, right? That is anti-clockwise. Now, the letter T there in red is very special because the rotation is 180 degrees and the direction is not mentioned, because if you were to move 180 degrees, it doesn't matter if you go anti-clockwise or clockwise, right? You will arrive at the same destination. So that is how you will get it, and therefore you will get the letter I. Okay, now, one important smart tip for all of you guys is this. Rotation of 180 degrees is actually a reflection. Alright, so when you come across a rotation of 180 degrees, it actually means it is a reflection as well. So this is where it doubles up, okay, to become a reflection. Only when you come across a rotation of 180 degrees. Alright, now let's take a look at this example together. Transformation R represents an anti-clockwise rotation of 90 degrees about the point 0, 0. Draw the image of object P under the transformation R. Alright, let's take a look at the diagram. So this is the diagram. Alright, what I want you guys to do now is to draw the image of this object P under this rotation. Again, anti-clockwise, 90 degrees about the origin. Alright, so why don't you guys try it out and we will draw it together a short while later. Alright guys, let's take a look at this object right now. Alright, so we have to, when you come across a rotation, you must be alert of the details. Alright, like what angle? In this case, it is 90 degrees. What direction? In this case, it is anti-clockwise. And the center of rotation, because the center of rotation doesn't move. The object rotates around it. Okay, so let's take a look at this object, and we have the object P right now. Okay, so I'm going to actually rotate it according to the question, which is anti-clockwise, and the center of rotation is actually 0, 0, which is the origin. So this is the center. Okay, and we're going to rotate it around. So just imagine that this is the hand of the clock, and we're going to rotate it anti-clockwise, which means it is moving in this direction. Okay, so this is the anti-clockwise direction, so just imagine it moving, alright, anti-clockwise to a position of 90 degrees, alright, then it will stop. So how do we actually find the exact image? Okay, so remember, you can't just sketch it, it has to be accurate because it is in a graph. So what you have to do is firstly, pick any point. Okay, I will pick the point closest to the center of rotation. Okay, so it is this point right here. And what I'm going to do is I'm actually going to draw dotted lines to the center of rotation. Okay, so this is what I will get. See, dotted lines. And now what I have to do is to, because it is 90 degrees, I have to form an L. Okay, and it has to be 90 degrees from the center as well. And I can get it right here. Can you guys see that this is actually a 90-degree angle right here? Okay, so this point will actually end up right here. Okay, so this is how you go with, alright? So remember, it is 90 degrees anti-clockwise, so it is moving there. So this doesn't move. Take it, draw dotted lines, and make sure they are equal distance and they form an L. Okay, now let's find other points as well. I'm going to use this point right here on the top. Same thing, all you have to do is join it to the center of rotation, which is the origin, okay, and draw dotted lines. Okay, alright, now, so this is further away, so you have to stop. Okay, so use your ruler and try to formulate the position of the L. Okay, so where will the L be formed? And you have to actually practice. It will be formed right here. Okay, so you have to actually do it slowly. Okay, so that point will arrive there. Okay, so it is still not enough to determine the image. What about this point? Okay, so same thing goes. Connect it with a dotted line until you meet the center of rotation. Okay, and then be very careful, just focus on this dotted line. I know there are quite a few dotted lines, but take a look at this line. This is the L that you will get. Okay, so can you see? This is an L right here. Okay, and finally we have the last point, which is this point. Also same thing goes, okay, draw dotted lines, okay, until you get it, all right, and try to form an L. So where will it be? Okay, check this line, make sure it is in the anti-clockwise direction, and you will get that it is going up right here. Okay, so this is the point. So now, when you actually got all vertices already, you can join them by using a ruler. Okay, so make sure you actually join all of them nicely. So what I will get is basically here to here, here to here, here to here, okay, and lastly here to here. Okay, so can you see that we have actually rotated it anti-clockwise? Okay, so the rotation actually involves more practice. All you have to do is be patient, go point by point, connect it into the center, and try to visualize the movement. Alright, so with the rotation done, okay, so what you have to do is right now just to get the idea of it, alright, every transformation. Let's go on to the final individual transformation, which is the enlargement. Enlargement occurs when all the points on an object moves from a fixed point, known as the center of enlargement, to form an image according to a certain ratio, known as the scale factor. Alright, so this is just what you call as the properties of an enlargement. You're actually resizing an object. If scale factor of 2, it means that the object is enlarged to 2 times than its original shape. If the scale factor of half, it means it reduces the size of the object into half. If scale factor is 1, the image is the exact same size as the original object. Alright, so the enlargement is the only transformation where the image is different size from the object. Look at the earlier 3 transformations that we have done. Translation, reflection, and rotation. No matter how you translate, no matter how you reflect, or no matter how you rotate it, the image will always be the same size as the object. But enlargement is the only transformation where the image is either bigger or smaller than the object. That is why the enlargement is actually categorized as a non-isometric transformation. Alright, now let's take a look at this diagram. We are going to focus now on finding the center of enlargement, alright, because 2 things are important, the scale factor and the center of enlargement. What do you notice about the 2 shapes? Alright, apart from it looking like J, alright, what do you notice? One is bigger than the other, right? Similar shapes, yes, they both look like J's, but different sizes, one smaller than the other. Now, imagine a line passing through the top left-hand corner of both shapes. Okay, so what I'm going to do is now take a look at this diagram. Every corresponding point. Okay, so although they are at different positions, when we actually choose corresponding points, top left hand or top right hand corner, and when I just join them together and prolong the lines, they will actually intersect at a common point. Continue drawing other lines to join their corresponding corners or vertices of the shape. So what will we get? The lines will eventually meet at one point, okay, O. The point is called the center of enlargement. So guys, take a look at this diagram again, and this is how it will look like. Alright, this is the technique in order to find out where the center of enlargement is, alright, because every enlargement always comes out from a center. Alright, and that's how you find it, alright, by drawing lines until they intersect at one common point. Alright, now let's go through this example and the details again. Find the distance of O to A. Answer, OA equals to 4 units, alright? In the earlier diagram, find the distance of O to A prime. Answer, OA prime equals to 8 units. Scale of enlargement. OA prime over OA, or 8 to 4, is equals to 2, which means the image is actually double that of the object. So all we have to do is to compare certain lengths and ratios, and we will get the scale factor. Alright, now I want to take a look at both of these objects. Alright, we have 2 objects which are in the shape of a J. Now I want to take a look at a smaller one. Alright, it has the labelings P, Q, R, S. And the larger one, P prime, Q prime, R prime, and S prime. Alright, just to label their corresponding corners. Okay, now what are we going to do? Let's find the length of P to Q. Alright, where is PQ? Look back at the diagram and you will notice that it is the top length, alright, and it's actually 3 units. Now, find the length of P prime to Q prime. It is the same corresponding length but in the enlarged image. Answer 6 units. So the ratio of P prime Q prime, that length, over the length of PQ is actually equals to 6 to 3, which gives you 2. And that value is the scale of enlargement. Alright, so that is what you will get. Alright, so remember, in enlargement, scale factor is important and the center of enlargement. So every transformation has important features or aspects. Now, let's take a look at this example. Enlarge these shapes from their corresponding centers of enlargement with a scale factor of 2. Okay, so we have actually gone through many examples like this, alright, just to get an idea of the transformation that we are talking about. So I'm sure all of you will get an idea of this. We have 3 objects right now. I want you to actually imagine and visualize what will you get, what letter, when you enlarge it with a scale factor of 2 about the dot. Alright, now let's take a look at the solution. This is what you will get, alright? So when we enlarge an object, it has to follow the following techniques. Alright, so enlarge the top one, for example, you will get the image twice, alright? So every image is twice the object. Alright, and this, when you combine it, what will we get? We will get a letter C. Okay, so when we actually enlarge all of them at the same time, that is what you get. Alright, so remember what you must do. Alright, now let's take a look at one more example. The diagram below shows object A and B on a Cartesian plane. Object B is the image of object A under a transformation E. Describe transformation E. Alright, so now let's take a look. This is the diagram. So B is the image of A under a certain transformation. So how are we going to describe it? So obviously it is an enlargement, but it is not enough just to mention enlargement. You have to mention it in full. Alright, which means scale factor, center must be there. So let me just show you how to enlarge and how to actually describe this enlargement. Alright guys, let's take a look again at this given diagram. So we have 2 objects, alright? So A and B is the image of A. So it is obviously bigger, right? So it is definitely an enlargement. Now, we have to describe it, and we have to describe it completely. So it is an enlargement of how many times? What is the scale factor? Where is the center? Alright, so we have to go through, alright, the process to find both of them. Alright, let us find the center of enlargement first. Alright, where does it come out from? Alright, in order to do that, what must you do is like this. Pick one corner of the object, and pick one corner of the corresponding point on the object, on the image. So this is the top, right? And this will be the top as well. Okay, what I want you to do now is to draw a line that passes through both of them, because they are actually similar points, but just on a different scale factor. So where will they? Okay, so actually just draw a line connecting both of them. Okay, so you will get it actually coming out from here, right? Okay, now pick this point. Its corresponding point on the object is this, right? We are choosing the same point. They are called corresponding points. And then why don't you guys just draw, alright, and connect them? Where will they arrive at? Okay, so when you see, they will arrive right here. Okay, alright, choose this point. It will be this point, right? They are actually equal points, alright, just on, okay, different positions. So join them. Okay, and you can also choose this point as well. This point will come here. So when we actually do it, it will be right here. Okay, so we have actually drawn lines, okay, that connect the corresponding vertices. Where do they meet? They meet at the origin. So this means that the origin is actually the center of enlargement. Okay, so we have got one of those information. What about the scale factor? Alright, in order to determine the scale factor, alright, we just have to pick one of the sides. Alright, and the best sides to pick are the vertical ones or the horizontal ones. Alright, don't pick the diagonals, because the diagonals are very hard to compare the lengths. So if I were to pick this side, alright, take this side for example, alright, again. Okay, so how many units are there? This height. 1, 2. Alright, I'm going to compare it with its corresponding height right here. So this is the line again. I just draw it more bold. How many units? 1, 2, 3, 4. So from 2 to become 4, how many times? It is actually double, right? So the scale factor is actually 2. So now if we were to describe it, this is how you will describe it. Alright, so it will be an enlargement, alright, with scale factor 2. Alright, because it is double the image compared to the object. Okay, where is the center? With 0, 0, or the origin as the center of enlargement. Okay, so this is how you actually describe an enlargement completely. You have to mention the scale factor and you have to mention where is the center of enlargement as well. So alright guys, with that we have managed to cover the 4 kinds of transformations, alright, in the previous lesson and this as well. So before we end, let's take a look at a quick review of what we have learned. The 4 types of transformations are translation, reflection, rotation, enlargement. Translation, reflection and rotation are isometric transformations, as the image after these transformations has similar shapes and sizes as the original object. Enlargement is a non-isometric transformation, as the image is either bigger or smaller than the original object. Alright, so if you have and categorize them, translation, reflection, rotation are categorized as isometric. Iso means same, metric means same size. Alright, and enlargement is the only non-isometric transformation. Alright guys, so thanks for watching. That's all we have for you right here in this lesson. Alright, see you in the next lesson for more regarding transformation. So until then, it's goodbye.